Okay, so uh, this session and a few sessions will be on deep learning. So deep learning is a very important aspect because nowadays it's used a lot in the learning part, especially because it can be used for all sorts of modes. Like it can be used for speech, it can be used for natural language processing, it can be used for images. So because of that, it's become very popular, and it's also known to give very good performance as compared to other learning algorithms which we studied up to now. So I'm going to concentrate a little bit on some of the deep learning architectures which are there. So, so what we need to see is that what is feature engineering, because if you look at any machine learning algorithm, you find that it consists of patterns which have some particular features, and depending on the feature values, you will be able to say what is the class label of that pattern. So obviously the features which you are going to use are very important. For example, if you use a feature which does not capture the class label, then such a feature is of no use. So what you need to basically see is what are the best set of features which you need to use. So this feature engineering is a very important aspect of machine learning, and generally what is done is it's manually designed. Okay, so you need to instinctively say that this feature is good, this feature is not necessary, etc. So in other words, it is an art also. Of course, it is a science also, but it is an art. So, so the feature engineering is the process which takes the raw data which is available and transforms it into features which can be used. So some of the raw data may be having values for the features as it is. Some of them you may need to transform. So, for example, if the raw data that you have is say x, maybe you need to take something like 1 by x or root x or something, some way of changing the value of x. That is, you will need to transform it in some way before using it. So that's also possible. So obviously the features that are used are very important for a classification algorithm. If the features are correct, then your classification accuracy will definitely be much higher. So that is feature engineering. So what do you do in feature engineering? Okay, first of all, um, we have a set of data, right? So we suppose we consider all the data, each of that data which you have is a feature, right? So you got to see which are the unnecessary features which you are using. Okay, so we saw when we were doing things like decision tree that there may be some unnecessary features. Okay, so we saw there that the sound that the animal makes is an unnecessary feature, right? So in this way there may be unnecessary features. For example, if you are trying to distinguish between a table and a chair, right? So maybe the color of the table or the chair would not be a necessary feature, right? Next is redundant features. So there may be features which are redundant. You may have to remove those. And out of the features that you have, you can sort of create new features, okay, which is known as feature extraction basically, which means you combine the existing features, transform the features like I said, use features from the context, integrate other sources of information, etc. Right? So these are ways to create new features. And then you may have to modify some feature types. For example, from binary to numeric, right? So you may have something which takes the value, say, true or false. Maybe you want to change it to 1 or 0, or you may have something which is say 0 and 1 and you want to make it into real number. So you may want to change it to 0, 0.0, 1.0, etc. So in this way you need to do all these things in feature engineering. Now if we look at deep learning, what is it that we are doing over here? Okay, so this thing on the left side shows you your standard machine learning algorithm where you take the raw data and you got to use hand engineered features, and after that you have to feed that into your trainable classifier to take a decision or decide which class label, etc. But in deep learning, what you're going to do is you're taking the raw data and you're going to feed the raw data into your deep learning algorithm, and the features are automatically extracted by your deep learning algorithm, and then that is fed into a classifier to get your decision. So what happens here is that you don't have to carry out feature engineering when you do deep learning. So that is a very big advantage when you are using deep learning. Okay, so you just take whatever raw data you have, you feed it into your system, and it will carry out the feature engineering. So what is deep learning basically? Okay, so deep learning is a class of machine learning techniques where you have many layers of information. So we saw in the neural network, so it is something like a neural network because it has layers connected by links. Okay, so it's just like a neural network. You have nodes which are connected by links, and you have it in the form of layers. So what you find is the nodes from one layer are connected to nodes from another layer, but nodes from the same layer are not connected to each other basically. Okay, so you have many layers, and this many layers are exploited for some type of feature learning which is carried out, and then after that is done, pattern classification is carried out. Okay, so there are different types of deep learning algorithms, deep belief nets, okay, probabilistic generative models, okay, Boltzmann machine, a network of symmetrically connected units which makes stochastic decisions of whether to be on or off. Then you have restricted Boltzmann machine where you have some visible units and some hidden units. And then we have the deep neural networks. So the deep neural networks are like the multi-layer perceptron. So the multi-layer perceptron we saw earlier had two hidden layers. Okay, but when you go to deep neural networks, you can have a number of hidden layers. Okay, so that's why it is known as deep basically. Okay, and then you have the deep autoencoder. Okay, so this is a deep neural network whose output is the data itself. So the output is the same as the input. So let us look at some definitions of deep learning. So the first one is that it exploits many layers of nonlinear information processing for supervised or unsupervised feature extraction and transformation, and then for pattern analysis and classification. And you can say that you have many layers, and the higher level features and concepts are defined in terms of lower level ones. So you find that Earlier in the deep neural networks, when you feed the input into the deep learning algorithm, you find that you have the lower level features, and these lower level features combine together to get higher level features later on. So, the higher level features are defined in terms of the lower level features. Then if you go on to some other definitions, it's a subfield of machine learning based on learning several levels of representation, right. So, you look at it as learning representations, representation learning, okay, corresponding to a hierarchy of features or factors or concepts, where high level concepts are defined from the lower level ones, okay. Then you can say that you can call it an area of machine learning definitely, um, introduced with the objective of moving machine learning closer to artificial intelligence basically. So, the reason why you would say this first of all is that the type of performance that you are getting with deep learning methods. Okay, so the performance is really phenomenal as compared to other machine learning algorithms. So that is one reason. Another reason is that you have data which you can use of different types which can be input into your deep learning algorithm. For example, you can have natural language processing. So, what you have is text. So, you are feeding text in as your input, and this text is then used, and you can get the performance, and this leads to some very phenomenal applications. For example, things like summarization, finding the parts of speech, okay, even generating new text, etc. So these type of things, and if you come to images also, you have first of all image generation. You can generate new images, you can classify images, and there are a whole lot of things you can do with images basically. And similarly with speech, okay, so you can convert speech from one language to another language. You can recognize the speech understanding. Okay, so there are a lot of things which can be done with deep learning. Therefore, you say it's coming closer to artificial intelligence basically. Okay. So, why do we say it is better than other methods? Okay. So, deep learning means using a neural network with several layers of nodes between the input and the output. And because you are using several layers of nodes, you find that the features are moving from lower level features to higher level features, and because of that you are getting very good performance. So, these layers between the input and the output, they do feature identification and processing in a series of stages, okay, which they say is how the brain actually seems to do it. Okay. So, what is new in this? There was multi-layer neural network. So, what's the difference between multi-layer neural network and the deep learning architectures which we are looking at here? Okay, so what we had was basically either one hidden layer or two hidden layers, right? And you had what is called the back propagation algorithm, which was used to find the weights in this network. But when we come to deep learning, you have many layers, right? So now if you use these many layers, and then when you need to carry out the training, if you have to find the error here, and if you have to use back propagation, you find that it is not possible to use it for so many hidden layers, right? So you find that there is what is called the vanishing gradient problem, because it becomes smaller and smaller and smaller, and it's not possible to do this. So what is used here basically in the deep learning algorithms is another algorithm for training. Okay, so what you are going to do is you are going to train one layer at a time basically. Okay, that's how it actually is carried out. So we can say these are some of the characteristics. First is feature engineering not required. Secondly, many levels will help to uncover lower level features in earlier layers and higher level features later on. And the problem is in training the many layers. Okay, so the solution is to train one layer at a time. So the training is done one layer at a time, unlike in the multi-layer perceptron. So you have something like this. So this is something like a deep learning, what is called the deep neural network. Okay, so we have many layers in between, and then we have the final node. Okay, so what is it that we do basically here? Okay, so what you do is you first train this layer. Okay, so what you are going to use here is encoder decoder. Okay, so it's nothing but an encoder which you are going to use. Then you train the next layer, train the next layer, and then finally you train this layer, okay, to carry out the classification. So what is it that each of these layers is actually doing? Okay, so each of the layers is trained to be an autoencoder. Okay, so basically it learns the output will be the same as the input. Okay, so if we look at this here, this is your output and this is your this is your input and this is your output, and you consider a hidden layer here. Okay, so if you take less number of nodes in the hidden layer and you train this as a neural network with this is your output and you keep the output as the same as the input. So what you will get is you will get the hidden layer containing the information in a concise way. Okay, whatever was in the input, same information you are putting in the output. So it is used like a autoencoder basically. So because you are using fewer inputs, okay, than the input, this forces the hidden layer to become good feature detectors. So these are the good feature detectors which you are basically using over here. Okay, so each of these is trained to be an autoencoder or a feature detector, as you would say, right? And then finally you are going to use this as the fully connected layer to carry out the classification. So what you basically get is that if you take layer 1, you may have features like this. When you come to layer 2, you can see the higher level features that are developing. When you come to layer 3, you have even more higher level features. Okay. Similarly here, if you take, suppose this is the input you are giving in. Okay, we'll see how the image can be transferred. So what you are doing basically is taking the pixel information, okay, and it's being concatenated. You have the first row, then second row, third row, etc. Everything is concatenated and it is represented in this way as a raw input vector representation. Okay, and then as you keep going, you find that you will have slightly higher and higher representations, and finally at the very highest level you may get something which says man, there's a man sitting or some such thing. Okay, so that's the highest level. Now why cannot we use the same method which we have used for multi-layer perceptron? So in the multi-layer perceptron is what you are doing is you are finding the loss here. Okay, so this is the actual output you're getting, and if your threshold is t, so t is the actual value. So t minus y gives you the error or the loss, okay, and you are going to calculate del loss by a partial differential of wij, that is the wij over here, okay, and so you are going to get del j by into xi. Now if you go to the next level, what you find is your del j will be sigma of del of j plus 1. Okay, del of j is j plus 1, which will be small anyway. So this will become even smaller, and you are finding the differential of this one, that is the activation function. So what happens is that this will be an extremely small number, okay, and you find that this del j will become very small, and as you keep doing it, you will find that it becomes smaller and smaller, and it may vanish altogether, like it may become so close to 0 that it would take it as 0. So that is the problem. You cannot use a multi-layer perceptron, especially if you have a number of layers this way, right? And as you go down the layers from the output, if when you're coming back, you find that this del j will become smaller and smaller and become difficult to use basically. Okay. So what you do is you are training this layer first, okay, and as an autoencoder, then you train this layer as an autoencoder, etc. Okay. So you are taking p of x and you are optimizing p of x basically, okay. Then you are going to train layer 2, etc. Finally, fine tune the labeled objective py given x, okay. So what you want is py given x by back propagation. So only this layer is done by the usual back propagation algorithm, just like you do in your neural network basically. Okay, so these are some deep network architectures, like I said, deep belief networks, restricted Boltzmann machine. Then you have recurrent neural networks, that is the RNN, and you have variations of the RNN, which is LSTM, and then the convolution neural network, etc. So these are some, there are others also. So let us see the categorization. One is deep networks for unsupervised or generative learning. So what are you doing in generative learning? You are actually finding the correlation in the data that is being given in, and you're generating new patterns. Okay, so that's what you're doing in the generative mode. So when you have class labels available, you can use Bayes' rule and turn the generative network into a discriminative one basically, okay. So we'll see some one or two generative networks later on. Then you have deep networks for supervised learning. So what you are doing is that you are given target label data which is available to you, and you use discriminative deep learning networks to actually make a decision or find the class labels of patterns basically. And then you have the hybrid deep network. So one such is what is called the generative adversarial network, where you are using a discriminative network to discriminate between patterns which are real and patterns which are generated. Okay, so which means patterns which are real and patterns which are fake, and this is used to update your generative network, and so you try to improve the performance of both the generative network as well as the discriminative network. So those that have both the generative as well as discriminative networks is what is called the hybrid deep learning networks basically. Okay, so some of the discriminative models we are going to study are like this. First of all, we'll see what the deep neural network is, right? And then we will see the convolution neural network and the recurrent neural network, um, and some modifications of the recurrent neural network, that is the LSTM and the GRU. And after that we will see the generative network. Okay, so the generative unsupervised models. In that we will see the generative adversarial network. Okay, so these are different models, but we will not go into all these models. So we'll see the generative adversarial network basically. Okay, and after that we will talk about the transformer model. So the transformer model can be used either in a generative way or a discriminative way. It's used for all types of data. You can use it for NLP, natural language processing. You can use it for um, the graphs or whatever images. It can be used for many types of things, speech, etc. So you find that the transformers have really improved the classification, and it's also very versatile, and it can be used for many different types of problems basically. Okay, so let us look at the tasks which we can do using the deep learning network. So basically we will put it into three categories. The first category is the natural language processing. The second category is the image data, and the third category is the speech data. Okay, so in all these three, what are the different types of tasks or what are the applications we can have, right? So in NLP, natural language processing, we can have something like text classification. Okay, so you classify the text as maybe belonging to some category. For example, you can say that this text belongs to the sports category, this text belongs to entertainment category, okay, this text belongs to politics. Okay, so those could be your class labels, classification. Or it could be, for example, if you have some text, you could, suppose we take computer science, okay, so you have a piece of text. So this belongs to machine learning, this belongs to databases, okay, so things like that. So that is classification of text. Then you have language modeling. So language modeling is used for things like language understanding, etc., right? Machine translation, that is translate from one language to another language. So you have something in Hindi, can you translate it into English? If you have something in English, can you translate it into Hindi or other language, English to French, French to English, okay, etc. English to German, German to English, etc. Then document summarization. So you have a document or you may have a group of documents. Now you want to summarize it, okay, in a few sentences. Okay, so that is known as document summarization. Then you can also have question answering. So that is you may have a text and you may have questions which need to be answered. So how do you find the answers to those questions? There are also things like combination of two modes. For example, you could have an image and you can have questions as text. Okay, so it's called cross modal basically. So you have two modes which are used over there. So we can see from this itself how very interesting all these problems are. Okay, so you find that in deep learning you get very interesting problems, and I think the horizon on what can be handled by deep learning methods is just too vast, right? And it's giving very good um, classification also. The second one is the speech. So what is it that, what are the problems you can do using speech? You can have speech recognition. So obviously you get a waveform, okay, of the speech. So what is it that it represents, right? Speech synthesis, so combining speech, machine translation, so translating the speech from one language to another language, okay. Speech synthesis is actually synthesizing speech. So you have maybe you have the information in the form of NLP and you want to convert that NLP into speech, okay, and you want to represent it and present it as speech, okay. So these are all applications for speech. And thirdly, we come to images. So images have very, very interesting applications. Of course, one is image classification. You could say something like if you have taken, say, a remote sensed data from the satellite, right? So you should be able to look at it and say that these are, say, cotton fields, these are rice fields, this is a road, etc., right? And of course, even in rural areas, right? This is a road, this is a building, etc. Okay, so that type of classification. Scene labeling. So, can you label the scene? Okay, whatever it is showing. For example, you may have a scene which consists of mountains and rivers, etc. So, can you label that? Next is what is called the image captioning. So you have an image and looking at that image, can you give a caption for that image? Okay. And that caption of course will be in the form of NLP. So this is again a cross-modal thing. Then things like human face detection. So which person are you looking at? Action detection, pose detection, saliency detection. So what are the important parts? Okay. Image detection. So all these are problems with images, right? So what we will see next is what are the data sets which are available. So you find that there are a whole lot of data sets which are available for all these type of applications which people use as benchmark data sets. So we will talk about those data sets in the next session.